Defining AI audit objectives and scope. Defining AI audit objectives and scope is a fundamental step in ensuring that artificial intelligence systems operate within legal, ethical, and performance standards. As AI technologies proliferate across industries, auditors are tasked with assessing these systems' compliance and ethical use. The process of defining objectives and scope is the cornerstone of an effective AI audit, setting the direction for the entire auditing process. This lesson explores actionable insights and practical tools that help professionals carry out this task effectively. At the heart of defining AI audit objectives is the need to understand the specific goals of the AI system under review. Objectives should be tailored to evaluate not only compliance with regulatory standards, but also alignment with organizational values and ethical principles. A critical first step is to identify stakeholders, including developers, users, and those affected by the AI system. Engaging stakeholders in discussions about the system's intended and unintended impacts is vital. This engagement helps in identifying key areas of concern, which can then be translated into audit objectives. For instance, if an AI system is used in hiring, objectives might include evaluating bias in algorithms and ensuring fairness and transparency in decision-making processes. The scope of an AI audit refers to the boundaries within which the audit will be conducted. Defining the scope involves determining the depth and breadth of the audit. Key considerations include the AI system's complexity, the data it processes, and the potential risks associated with its use. A well-defined scope ensures that the audit is manageable and focuses on areas of highest risk or concern. The framework for defining scope can be guided by the AI Risk Management Framework, which provides a structured approach to identifying and prioritizing risks associated with AI systems. This framework assists auditors in pinpointing the most significant risks and vulnerabilities, ensuring that the audit addresses these critical areas. Practical tools such as the AI Ethics Impact Assessment can be employed to systematically evaluate the ethical and social implications of AI systems. This tool provides a structured approach to assess potential impacts, facilitating the identification of specific audit objectives aligned with ethical considerations. For instance, an AI EIA might reveal that a financial AI system disproportionately affects certain demographic groups, prompting auditors to include objectives focused on assessing and mitigating bias. In real-world applications, defining AI audit objectives and scope requires auditors to navigate complex regulatory and ethical landscapes. A case study illustrating this complexity is the audit of facial recognition technologies used by law enforcement. The audit objectives in such a scenario might include assessing compliance with privacy laws, evaluating the accuracy and reliability of the technology, and ensuring that its use does not infringe on civil liberties. The scope, in this case, would be defined to include the data sources used to train the technology, the algorithm's performance across different demographic groups, and the oversight mechanisms in place to prevent misuse. The European Union's General Data Protection Regulation exemplifies the regulatory backdrop against which AI audits are conducted. GDPR mandates that organizations conduct data protection impact assessments for technologies that pose significant risks to individual rights and freedoms. Incorporating DPIAs into the audit objectives ensures that AI systems comply with data protection regulations, safeguarding user privacy. The scope of such audits would include evaluating data processing activities and ensuring robust data protection measures are in place. Statistics underscore the importance of comprehensive AI audits. According to a 2020 survey by Deloitte, 56% of organizations reported using AI in some capacity, yet only 26% have formal oversight and governance structures for AI systems. This gap highlights the critical need for well-defined audit objectives and scope to ensure AI systems are effectively governed and aligned with organizational and ethical standards. The process of defining AI audit objectives and scope is not static. It requires continuous evaluation and adaptation to emerging technologies and regulatory changes. The dynamic nature of AI technologies means auditors must remain vigilant, updating objectives and scope as new risks and ethical considerations arise. This adaptability ensures that audits remain relevant and effective in addressing the evolving challenges posed by AI systems. Frameworks such as the AI Audit Framework offer comprehensive guidelines for conducting AI audits. The AIAF outlines steps for defining objectives and scope, emphasizing the importance of aligning them with organizational goals and regulatory requirements. By following such frameworks, auditors can systematically approach the audit process, ensuring consistent and robust evaluations of AI systems. Moreover, collaboration with interdisciplinary teams can enhance the effectiveness of defining AI audit objectives and scope. Involving experts from fields such as law, ethics, and data science provides diverse perspectives, enriching the audit process. This collaborative approach ensures that audits comprehensively address technical, legal, and ethical dimensions of AI systems. In conclusion, defining AI audit objectives and scope is a critical component of conducting effective AI audits. Auditors must engage stakeholders, employ practical tools and frameworks, and adapt to the evolving AI landscape to ensure that audits are comprehensive and relevant. By doing so, they can address real-world challenges, safeguard against risks, and promote the ethical and compliant use of AI technologies. The insights and strategies discussed in this lesson provide a foundation for professionals seeking to enhance their proficiency in AI auditing, equipping them with the skills needed to navigate the complexities of AI systems in today's world.